Good morning. Welcome to the kickoff of the Red Hat Summit. We appreciate you joining us today for the very first breakout session. Also appreciate the standing room only. We know the agenda's packed with lots of good shows, and we're honored that you chose to join us for the very first one. This is my fourth Red Hat Summit, so who here has been to a Red Hat Summit before? All right, what about 2? About 3? 4? 5? Awesome. Excellent. So we are super excited to be here. We're going to be talking about the hot topics and 3 of my favorite subjects to discuss: containers, OpenStack, and Hadoop. And we're going to break it down. We're going to kind of start with the basics and then get into some more of the advanced topics. So I'm Dwayne, Director of OpenStack Product Management and Strategy for Cisco, joined here by Krishna, our lead architect in the data center group at Cisco. And at the end of this session, hopefully everyone will walk away knowing something that they didn't know before about containers, OpenStack, Hadoop, Cisco, or Red Hat. So we're going to start with, if the slides cooperate, we're going to start with containers. So who here is involved in creating a strategy for, proof of concept, or deployment of containers? Okay, all right, keep them up. What about the same thing but for OpenStack? Okay, and what about Hadoop? All right, okay, awesome. So almost everyone, right? These subjects are top of mind with everyone. They're all going 100 miles per hour, and we're going to talk about some of the hot topics and how they can be better together. And we're going to talk about the container ecosystem, some of the choices. Because we love open source, we're going to focus a little bit on some of the new ones from the Linux Foundation, the CNCF, Cloud Native Computing Foundation, as well as OCI, Open Container Initiative. And then we're going to talk about some of the container-related projects with the OpenStack Foundation and with OpenStack in general. Then we're going to try to change gears a little bit. We'll talk about some of the new product announcements, Cisco NFVI, Network Function Virtualization Infrastructure, as well as Mantl and Shipped, the microservices platform. Then we'll turn it over to Krishna. We'll talk a little bit about how to configure operational and security policies for containers. Then we'll talk about how to deploy Hadoop big data on Docker containers. We'll talk about Cisco's UCS infrastructure for big data with UCS and Red Hat OpenStack platform, and then we'll close with a brief summary and Q&A. So everyone is talking about containers, and I think it's important to understand a bit of the history and some of the milestones in containers. Containers have actually been around for a long time, since the 70s and Unix. You had change root, right? Actually changing the root directory structure in terms of what a process can access, right? FreeBSD introduced the concept of jails, things like account privileges. I mean, literally think of like jail cells. A lot of people think that the term jailbreaking a phone actually comes from jails in pre-BSD. Solaris took the concept to the next level with zones, added some things like snapshot cloning, interfacing with ZFS, Zero Files system. Then control groups, C groups, merged directly into the Linux kernel. The way containers are implemented today is control groups and namespaces largely. Then Cloud Foundry has Warden and Garden for containers and container orchestrations, right? And then in 2013, a little company called Docker got everyone's attention and did some really good things with containers. They started talking about an application container format, and as well as a hub repository to store container images. And then Rocket, CoreOS, introduced the Rocket standard, another container runtime, more modular, some say more secure. And then in 2015, last year, the Linux Foundation doubled down, created 2 initiatives around containers: CNCF, Cloud Native Computing Foundation, and OCI, Open Container Initiative. So everyone is talking about containers. But a lot of times people don't say why containers are important or why they're the buzz, right? They're the buzz because they're cloud native, right? It's no longer a monolithic application, if you will, that has understanding of all the infrastructure behind it. I recently was at another conference and someone was describing monolithic applications. They described it as artesian applications, which I thought was interesting. But containers are designed where they're not aware of the infrastructure underneath. You can build them once, run them almost anywhere. Like, in fact, the Docker tagline I have here is build, ship, run any app, anywhere. They're very portable, very easy to move between different cloud environments. Thank you. Oh, there we go. It's perfect. Thank you. Thank you. They're very lightweight. They share the kernel. They're very scalable, very portable. Instead of talking about, say, 50 VMs per server, you can start talking about, hundreds, maybe even thousands of containers per server. And they enable microservices. So who here was at the OpenStack Summit in Austin just a few months ago? Okay, excellent. So we saw the demos, Stack and Netties. OpenStack services in Docker containers. Delete the service, Kubernetes spins up a new version of the container in the service. But it's microservices, composable applications. It's a great way to build very scalable and very resilient applications. So let's take a look at some of the choices in the container ecosystem. So we have lots of choices. Linux containers, LXC, or LXD, the hypervisor, with some very interesting tie-ins to Nova for OpenStack compute. Cisco with Contiv, operational policies. Christian's going to give us a deep dive on that later today. Docker, Rocket. Intel Clear Containers has some interesting technology. It's actually based on Intel VT virtualization technology, right? Which includes things like SR-IOB, single root IO virtualization, and DPDK, data plane development kit, but they don't actually use namespaces for the containerization. So it's almost like a lightweight VM, which is very interesting. With containers, you can start talking about micro operating systems, like Atomic from Red Hat. It's a great one. We heard a little bit this morning about some of the tight integrations with OpenShift. Rancher, these are from the original Cloud.com people, the people who did CloudStack as part of Citrix. Rancher is very interesting as well. The Linux Foundation, CNCF, Open Container Initiative, as well as Microsoft, right? We've heard some great things between Microsoft and Red Hat at this conference already, and Microsoft has some interesting container technologies for both Windows Server containers as well as Hyper-V containers, so an actual container in a Hyper-V VM. But because we love open source, let's take a look about some of the open source standards from the Linux Foundation. So we have OCI, the Open Container Initiative. So both Cisco and Red Hat are premier supporters of the standard. The goal of the project is to create open industry standards about runtime format as well as image format. The very first project was around the runtime. It's RunC, right? So this was originally in Docker Engine. It's now open source, built on libcontainer, right? So RunC is essentially the foundation of the open container runtime image, and even the recent version of Docker is actually OCI runtime compliant. So lots of progress and success on the runtime part of the container. OCI has also started to define the image spec for containers. They think they're going to draw from the APPC spec for part of that. Red Hat is a big supporter of that as well. And this is kind of a very powerful idea because the concept is you create an application container one time and you can use it on a lot of environments. You can use it in a CoreOS Rocket environment, Docker environment, an Amazon environment. So lots of flexibility designed into the OCI spec. In addition to OCI, the Linux Foundation is also created and launched the CNCF, Cloud Native Computing Foundation. Again, Cisco and Red Hat, premier sponsors. I'm on the marketing committee for CNCF as well as part of the product management and strategy team. The goal of CNCF, because I know some of you may be thinking, why does the Linux Foundation have two container initiatives? Right? So the goal of CNCF is to define a new set of container standards designed by internet scale computing. And recently, a few months ago, they announced their first project under governance, little thing called Kubernetes, right? Who here is using Kubernetes today? Right, exactly. So very popular. This is all under the governance of CNCF. And they recently announced their second project, which is Prometheus for container monitoring, right? So we've heard the term GIFI, or Google infrastructure for everyone else, right? So here we have, CNCF taking two things originally from Google, Kubernetes and Prometheus. So essentially bringing GIFI, to all of us as well. So lots of excitement, lots of traction around CNCF, and also the first Cloud Native Computing Days is scheduled for August 25th, I believe. So maybe put that on your calendars because there's going to be some great stuff at Cloud Native Day in August. So this morning, we heard a little bit about Atomic, right? So it's a micro operating system, tight integration with OpenShift. So some of the advantages of Atomic, right? So it's very secure. It's built on SE Linux, because we've heard some concerns about security for containers in general, right? But also, you notice it's based on RHEL. So if you're using RHEL today, it's part of your part of your runtime. It's part of your server environment. You can put containers right on RHEL with Project Atomic. It's a very interesting technology. It's also part or supported by Project Magnum, which we'll talk about in a moment. So now let's take a look about some of the container-focused initiatives with OpenStack. So we have Project Kolla. Both Cisco and Red Hat are very involved in this. Right? The goal is to provide production-ready containers and deployment tools for operating OpenStack clouds. Right? So it essentially takes OpenStack services, puts them in Docker containers, and then manages them with Ansible playbooks. So the Liberty release of OpenStack supported, Ceph-backed storage, choice of distributions, including CentOS and RHEL. Could deploy in Big Tent at 100-node scale, right? Minimal operational dependencies. So that was a good start with Liberty. But with the Mitaka release, it was more of a focus on the operational side, right? Added security enhancements. Added the reconfigured diagnostic, right? Named volumes for persistence. New services, right? Including Elasticsearch, as well as Manila, NFS storage for OpenStack. So lots of enhancements around the Kolla project as well, essentially making a better OpenStack with containers. In addition to containers, there's also the Magnum project, of which both Cisco and Red Hat are key parts. So the nice thing about Magnum is it basically makes containers a first-class resource within OpenStack. So you have VMs with Nova, you have bare metal with Ironic. Personally, one of my favorite project names for OpenStack, Ironic. People like it so much they want it for bare metal, so that's Ironic. And then Magnum for containers as a service. So it's multi-tenant right off the bat. It's very scalable, asynchronous API, so it's extremely scalable. Uses the same orchestration and identity mechanisms as other part of OpenStack, so Heat and Keystone, so it leverages all that technology. So single sign-on for cloud, very nice technology and a very good architecture. So the architecture is designed using Heat templates. Oh, there we go. You just got to use your imagination on what the architecture should look like. So picture, if you will, right? So you have Heat using orchestration templates, right? A choice of orchestration container technologies. It supports Kubernetes, supports Swarm, supports Mesos in the new release. And one of the nice things about the architecture is in the Magnum release, it actually supports pluggable networking, and Cisco and Red Hat were big parts of that as well. So you no longer have to use kind of the default flannel networking. You can use things like Weave, for example, or Calico. So Calico is an interesting project. It's part of Project Mantl, which we'll talk a little bit about later today. But it's compatible with most major platforms. So it supports OpenStack Neutron. So it supports OpenStack. It supports Docker CNM container networking model or libnetwork, so it supports Docker containers. It supports Rocket containers, so it supports CNI container networking interface. Right? So it supports a lot of environments. Red Hat and Cisco are big supporters of this as well. But it's a very interesting and scalable technology because in addition to supporting multiple platforms, it's not an overlay-based technology. It's all layer 3, and it has a virtual router actually in each compute node. So interesting technology with Calico as part of Project Mantl. So changing gears a little bit, let's talk about some of the recent product announcements from Cisco. So at Mobile World Congress earlier this year, we announced NFVI, Network Function Virtualization for Infrastructure. So NFVI is kind of nice because it's basically the best of both worlds. You have the flexibility of virtualizing the network functions, yet it's on turnkey infrastructure. So it's very easy to install, it's very easy to scale, it's very easy to do things like load balancing. It's built in partnership with our good friends at Red Hat and Intel. It's built on Red Hat OSP 8 or Liberty, as well as RHEL. It supports Cisco UCS for compute and storage, along with Ceph, software-defined storage. It supports Nexus for top-of-rack switch. Very nice networking plugins also. It supports OVS, of course, right? But it also supports VPP, vector packet processing. So very high-speed networking performance, and VPP is actually part of the new FDIO, Fast Data I/O initiative from the Linux Foundation. Also at Cisco Live Berlin, we also announced the Mantle and Shipped program. So who here is going to Cisco Live in Las Vegas in about 10 days? All right. Excellent. Marcia, you do not count, just so you know. So we're going to have a lot of good demos and announcements at Cisco Live also. But so Mantl was announced at Cisco Live Berlin earlier this year. And it's essentially Cisco's open source containerization platform. All right, so it's designed for running container and big data workloads. You know, it's very flexible, and it's at mantl.io if you want to take a look. And it's also the core of the shipped offer, which is essentially Cisco's kind of user experience for container development. So shipped is cloud native. It supports all the Cisco APIs, or some of the Cisco APIs. It's got CI/CD systems built in, you know, and the tagline is build, deploy, and run. Have your idea up in production in 5 minutes. So check that out at ciscoshipped.io. Once you have the containers created, you're going to want to configure some operational policies around it, including security policies. So now Krishna will join us for a deep dive on operational and security policies with Contiv.
Hello? Oh. Okay. Hey, thanks, Dion. So what I'm going to do is more focus on what are the challenges with container deployments and what are the applications where it's being used. One is, you know, I'm focusing more on big data. And also I'm going to talk about Hadoop-as-a-Service based on the OpenStack Liberty, which is OSP 8, right? So this one is going to talk about how do we overcome the challenges of productionalizing. In enterprise, if you look into it, so the containers are good. So I've been working on various companies, especially the companies like, you know, the Facebooks and Yahoos, Netflixes. They have their own you know, teams which can build and maintain, you know, their own homegrown solutions to deploy, you know, almost like container-like environments. But if it has to be implemented in enterprise, so what Cisco, from Cisco point of view, how do we produce a production-grade or enterprise-grade container services, right? So Contiv is one such product. So what we talk here about the scale. So how many of you are using containers in production? Good. So that shows that the acceptance is not there yet in enterprise because of the challenges. Slowly we are reaching that. So one of the things is the scale. So if you look in today's you know, enterprise, so it may be IT running as IT as a service or software as a service. We're talking about hundreds of nodes supported on a VM or on a bare metal provision, right, per host. That's a challenge. And this need to be clubbed with a lot of application packages, right? We are packaging more and more into the containers. We're talking about different types of applications like web services, web servers, app servers, DB servers. All these things are packaged. And second thing, we are talking about the speed. So when you want to bring up these containers, you are talking about the speed of, you know, minutes, not hours and days. So, and also all the components underlying it. So network is a crucial thing from the Cisco point of view. And if you look into the storage, compute and network, which is attached to the container, need to scale and come up in number of containers you are deploying on a host. That need to happen concurrently and need to come up in minutes. And so next thing what we're talking about is basically on like the application infrastructure itself. So if you look at the layering, right? If you can types of layering we are seeing, we have got the VM, we got the container, the VM, and the physical layer. And so this is the challenge, right? So how do we, there is a performance kind of penalty we are giving because of multiple layers of orchestration is done while getting the container up, right? And next thing is about the application infrastructure. So far we have been dealing with infrastructure. Now it is application centric versus infrastructure centric. What is happening in one of the things which Dion mentioned about cloud native, right? What is cloud native? Do we know what the difference between cloud native applications, which is technically the mode 2, and the cloud, prior to cloud native, were all web scale applications. People thought of and were doing like application deployments based on the HA kind of load balancers, etc. Today, it is based on the traffic. So more traffic, more applications. We need to scale linearly, right? And we need to be able to shrink this application as we come down. So that's the biggest challenge. So what that opens up what we call as composable infrastructure. So composable applications are happening. Many people are doing it. So what next thing would happen is composable infrastructure, right? We would be able to spin up applications which are attached to this compute network and storage on demand. We need to be able to scale. We need to be able to scale up and scale down. So that's what we are talking about. Oops. Okay. Now we're also talking about the shared resources. So with this complex environment, we're talking about resources are being shared because we're not talking about a single tenant. We are talking about multiple tenants. So in that, how that whole, think of like a VPC, Amazon VPC. If we were to bring an Amazon-like experience in the data center, that's what is more about cloud native applications and cloud native infrastructure is all about. Companies like Cisco, Red Hat are joined together to bring that kind of an experience on the data center. And then we are talking about like hybridity. So this is an interesting thing. How many people today are having challenges or are planning to move the workloads between on-prem and off-prem? Any use cases? Okay. So this is going to happen because what we call as cloud bursting is one of the interesting things which is going to happen. So people want to experiment everything on their data center and would like to move it to a larger either data center or into any of the public clouds. So hybridity is becoming key. So in hybridity, important things are consistency, security, and also connectivity. These are the key things for the hybridity. Then we're talking about security. Security is one of the most challenging thing which is evolving. It is ever changing. As the requirements are coming up, especially in terms of hybridity, in terms of cloud native, the security becomes an important thing. So the most crucial things we see in security, which we would like to address using this infrastructure is, one is tenancy, multi-tenancy. Second thing is isolation and compliance, right? Compliance becoming a big thing today. So you were talking about HIPAA, PCI, Europe, and data in EMEA. All those things are becoming a kind of interesting challenges to solve. So now the next and last but not least is how do we diagnose this environment? Can we do telemetry? Can we enable the logging? Can we enable the real-time insights into and monitoring these environments? This is another challenge. So all these things are the today's challenges for the production-ready environment or production enterprise class, enterprise-grade IT services environment. So Conti will try to address those things. So this is the typical architecture. It is a metadata managed. We have different stacks, like we have Conti Manager, which manages different policies at network level and which can operationalize your enterprise systems, right? So using Docker deployments. And this can be used for large Docker deployments like large container deployments, 100 to 500 nodes. So now what do we do? How are we integrating this within Cisco? So now one is with, I think somehow some things are again something blanking out. So that is ACI, our application-centric infrastructure. It has an Epic. It has been integrated with Epic. I'm sorry for that. Something happened in the slides. We are blanking it out. So Epic has been integrated, and also we are actually integrating with Nexus, the standalone 2K, 5K, 7K, and 9K switches. And also the last one is about UCS. With UCS, we are supporting both B series and C series of infrastructure, right? Now, let us take an example of another example. We just talked about how do we manage policies, how do we manage production grade kind of deployment scenarios using Contiv. And the second thing is, how are we deploying Hadoop as a service using Docker? So that's another big data application. How many of you are using Hadoop as a service? If not standalone or, anything. Okay. So, so there is a lot of difference between Hadoop as a service and just a standalone Hadoop. Hadoop as a service is becoming a challenge in the sense that IT organizations would like to provide this to the end user, an application developer, a small tenant or a node, maybe 3, 4, 5, 10 nodes. That's one use case for QA and development purposes. Another thing is data scientists are predominantly looking for creating a small clusters to do some research. It could be data scientists doing security analytics or a data scientist doing financial analytics. It could be anything. So the requirement of creation of Hadoop clusters on demand and in a composable way, bring it, create it, do the research, throw it off. That's creating a big need for Hadoop as a service. In traditional ways, we are actually doing Hadoop as a service. Technically, standalone Hadoop takes like weeks, right? So these things, I'm going to talk about that next. When we have already built and published solution, and shortly we'll be doing our CVD on OSP8, which is based on the Liberty, which is going to tell us how simple it is to install and configure. Once it's all done, you need to just go on creating different sizes of Hadoop clusters for different requirements. In this case, if you already know, how many of you are using Docker? In production or in QA, anything? Okay. So again, so the Docker has two, again, as my friend has already mentioned about it. So we have standards. So one of the big thing is there is no formal standards, right? So what Cisco is doing along with Red Hat is coming up with standards. So one of the things we are doing is what are the real applications, right? Where are the pain points? For example, in big data cluster deployments, we're not only talking about Hadoop, we're also extending into things like Cassandra. We're working with the partner ecosystems, and also we are working with Kafka. We are also deploying large Kafka installations that all need to be deployed in a consistent way. That's where we can use containers, or Docker is one of the big examples. So there are two things, like there is a view of DevOps and there is a view of an operations developer. So as a developer, what I want to know is I want to have least dependencies on packages, because I want to, if all the developers go through this pain, the problem here we say is I need to go and I need to update certain packages and certain things are not working. This is a common problem with people. So if we create a golden image of a Docker file system or a Docker container that has got every single bits tested, validated for a developer, sandbox, then everyone can use that. So that simplifies the whole developer experience. And another thing is Docker is basically VM without the overhead of a VM, and it's lightweight. And also it gives you a very cheap way of creating a simple container-based file system, which will give you, a consistent development environment. The same thing, that means you can use the same thing with, I will call as SDLC. It is software deployment lifecycle. You can think of like a software development lifecycle, deployment lifecycle. We can create, migrate, rather promote. That's the new way. You can go from dev to QA to staging to production in a consistent way. You don't have to bother about so many configuration files, which is going to create a real big problem in production, deployments. So that's where we can use Docker. That is for the DevOps use case. So what we have done, we have in this particular example, we are using Hot and Data Platform. This is one of the use cases we are doing. And also we use Ambari, right? So we have created clusters based on the Docker for the, and also Hot and Data Platform. So, and also we use Swarm and Console for discovery and placements of different nodes. This is all based on the UCS environment. I'm going to talk about what are the details of the UCS in the next section. This is a real thing, in fact. We're working on this, and we would be showcasing probably at Cisco Live. If anyone wants to take a look at it, we'll have something. I'll quickly go through this. This again, using the blueprints, we will quickly deploy, and we can move that from one application environment to another application environment, and almost seamlessly, in the sense that we don't have to bother about the configuration files and all those YAML files which you may be dealing with. All this thing will happen almost in real time. Okay, so what are the key benefits, right? So as I said, the key benefits are you can run the same consistent image across all the environments. That's one of the key things, right? So now let us look into the another aspect of the supporting infrastructure underneath this Hadoop as a service. So why UCS is suited for this? UCS is an x86 based platform. And what are the benefits of it? So we have infrastructure, okay? We have operating system, we have data management. On the top of it, we can run a variety of applications, right? So how many of you are using UCS? Cool. Okay, so this is the power of an infrastructure, which is, as like vetted, validated using CVD, Cisco Validated Design process, on which we have built Hadoop-as-a-Service. So Hadoop, how many of you are using Hadoop? Oh, that's good. I mean, you see more number of people. So how many of you are using other forms of big data like Cassandra or maybe Kafka, etc., like complex? Okay, so good. So Hadoop doesn't require any introduction now. It is the 10th year of its incarnation. So it is a distributed processing system. So the biggest difference, I'm not sure how many, I would just like to do some education here. So if we look into the SQL workflows, SQL patterns, the way we used to take the storage to the compute, look into any traditional databases, right? Now with Hadoop, we are actually taking the compute to the storage and distributing that processing. That's all about this Hadoop architecture in a nutshell. So this is the typical ecosystem with Yarn, which is Hadoop 2.0. Underlying, we have HDFS. We have a variety of tools, and also we have Zookeeper to manage the nodes. And also we got two plugins. One is Flume, basically for logs, and Scoop is basically almost like a driver. There's a connectivity for SQL. And on the top of it, we have Ambari for monitoring, orchestration, cluster management, etc. This is a standard Hadoop ecosystem. So this is Hadoop-as-a-Service. So that's what I just mentioned. Hadoop-as-a-Service need to have one thing. It has to be elastic. It has to be scalable, right? It has to support multi-tenancy, right? So there are lot many things will go with multi-tenancy. All of these are features of Hadoop-as-a-Service. So these are the with the best of the breed technologies from Cisco and OpenStack, Red Hat, we are building Hadoop-as-a-Service, which actually gives you all the flexibility in terms of operationalization, quickly spinning up nodes and bring down nodes, and also multi-tenancy, chargeback, all those things are coming. So this is one of the things I would like to talk about. We have published Cisco Validated Designs and architectural bundles. We go all the way from C220s, which basically we can support what we call as the starter kit or a starter. And we can go all the way up to C3160, which is basically an extreme capacity. So that means in C3160, when fully loaded, we can take up to half a petabyte. We are in the 4th generation of the technology today. So these are some of the highlights of the solution. So if you look at it, we are into many verticals today. This business alone is growing at a very rapid rate. Almost 60 to 70% year over year. Today, this year, we're doing almost like 400 million. And second thing is we got the best partnership with all the ecosystem partners. I'm going to talk about it. And second thing, if you look into this is the IDC. We are not saying the IDC is saying. So one of the best ROIs. So you can get the return on investments. The break even is only 5 months. In 5 months, you will recover all the investments. And also this is compared to the industrial competitors. These are the numbers we have. The numbers speak that why this is most efficient and most interesting product where you can build big data services. When I say big data, we're not just talking about Hadoop. We're also talking about things like Cassandra, MongoDBs, and also things like Spark and Kafka. And on the extreme right side, what we support is called UCS domain. Each domain supports up to 5 petabytes. So there is technically no limitation. You can expand as many petabytes you want, but every 5 domain, one domain supports 5 petabytes. You can have multiple domains if your data requirements are higher. So these are the ecosystem partners. So we got data management, data integration, and analytics. We have most of the best brands available. Right? So this is it. This is the value proposition from Cisco. Single point of single window. So this is the process of Cisco Validated Designs. So what happens is the process is so we do all the uplift. We'll do all the vetting of the solution. Every new release comes with the new generation of hardware. It has been tested, and the validated designs are published, where you can pick up all the information about what the latest and greatest, and also look into what the configurations are there. And second thing, another interesting thing I would like to tell, we got the best performance benchmarking in the industry. Okay. So these are the integrated infrastructure. Okay, the benefits of it. So let us talk about OSP8. So OSP8 is based on Liberty. So fundamentally, you all know this is the latest version, the production version, and the concepts we use are basically in overcloud and undercloud. So undercloud is basically the management platform. Overcloud contains like network storage. It controls that. Let me go back to, okay. This is the undercloud. Undercloud manages everything. Basically, it's kind of a management node. Undercloud manages and installs the overcloud. Overcloud is another part of the architecture. So this architecture is called triple O. Okay. Overcloud and overcloud. So one of the advantages of this architecture is it is highly scalable. it uses different types of storage it can support, and also it can also support both architecturally and also in scalability wise. You can have things like other CEF is another storage which is coming up, and you can also use your object store if you want, or Swift. So this is a typical architecture we have. In one of our reference architecture has, we got compute and storage and network, and we got 3 controllers and 1 NFS and storage. This is the typical architecture we have running in our CVD as Hadoop-as-a-Service. So, any questions? Now we are almost at the top of the hour, and I'll also call Dion to join me. So,
thank you. Good job. Yes.
What can you repeat it?
So under the UCS, 5 months to get back the investment you mentioned.
Okay. So okay, I'm going to tell you. So I know that you are asking about on the ROI, right?
Yeah.
Okay. Yeah. I'll tell you. We got a lot of information on that. Right. So this is coming from Gartner. What we do is we work with our partners and also implementation partners. We will take, Gartner looks into all this data which is available from the market. So we take a specific use case. Again, these are all large installations, by the way. They're huge installations, they're not small. So we have, one of them is running several, probably close to about 1,000 nodes. So this is a very large enterprise customers. We take the benchmarks, we compare with other partners, work with our partners, compare with the competition, and find out how we are comparing against them, and these numbers are derived. It's coming from an IDC. So the use case could be, we support most of it for retail, right? Finance, healthcare. And you can, there is a page and big data, there is I can send you the URL, and we can give you all the details. You can look into all the real use cases and also all the data which is available on the net.
Was that a return on investment compared to one, compared to other integrated solutions, or compared to running on a mainframe?
It's not running on a mainframe. It is.
I'm saying you haven't told us what you're comparing.
So there is, the comparison is with basically if you are to run with XYZ company, products or solutions, our solution is, this is what our solution gives.
What are you comparing it to, the return on investment?
Return on investment is, one is number, your cost, your investment in terms of infrastructure, your investment in terms of the people who make the things happen, like in the sense that we're talking about human power, like engineering power.
Right. It's an excellent question. In the report, they talk about the operational expenses.
Yeah.
So it's
CapEx,
compared
OpEx.
to CapEx is a part of it.
As compared to running it on Spark?
No, it's not Spark.
I'm saying,
No. This is Hadoop-as-a-Service. So this is not Spark. We're talking about Hadoop versus Hadoop. If I were to run this Hadoop-as-a-Service on OpenStack UCS, yeah, so that's all. So you can take a look at it, and we can share your details.
Compared to the environment before UCS. We can get a copy of the report for you as well. But it's an excellent question.
Yeah. Thank you.
Thank you. So we're getting told here we're almost out of time. So just to kind of briefly summarize, right? So the Linux Foundation, the new container initiatives that they're doing, the Cloud Native Computing Foundation, and the OCI Open Container Initiative, they are going to be very key to be defining new container standards, almost there. Also, the OpenStack Foundation projects like Kolla and Magnum are going to be key in terms of providing an OpenStack and container environment. Cisco Validated Designs for Hadoop, big help in terms of best practices and de-risking some of the solutions.
Yeah.
Please, visit the booth downstairs. Right as you go into the left, you can see NFVI as well as Calico and Mantl and Shipped and other Hadoop demos there as well. So, and on behalf of Cisco and our good friends at Red Hat, thank you so much for joining us for this very first kickoff to the Red Hat Summit. We're going to be posting the slides, including a few bonus graphics later, so this all will be available later this week. And I've been a top presenter at conferences before. My goal is to be one at this Red Hat Summit. So if you thought the session was informative or at least enjoyable, please hook us up with a review. And we hope this is the best Red Hat Summit ever for you. Thank you.
Okay, thank you.